cis and trans isomers. The system related to alkenes. For example, we have this alkene, but both groups on the other end are the same. This is a cis alkene because we have the same groups above the plane and the same group below the plane. And if you have groups across, then we have a trans alkene. So this works well for substituted alkenes. But this system does not work very well if all the groups are different. Then in that case we cannot use the cis and trans. So there is a different system that was designed, and that system is called E and Z isomerism, or naming stereoisomers of alkenes. So this has 4 different groups. So for the E and Z system, we need to find which group on each side is higher priority and which group is a lower priority. So let's say on this side, if let's say B is higher than D, and on this side we can say maybe A is higher than C. Then we can say that groups of higher priorities, okay, and if groups of high priorities are showing on the same side of the double bond, this will be Z. That will be Z isomer. And then the other situation will be if we can still use the same system, only that in that case our higher priorities will be across the diagonals of the double bond. So over here we focus on the high priorities. I just focus on which substituents are higher priority. So in this case we have the higher priorities on opposite sides. So this is an E isomer or E alkene. For instance, we have this. So I have a situation where I have 4 different groups. This is a metal group, this carbon on the side, which is bromine, this is fluorine. So over here, this is high priority on this carbon. On this carbon, this is high priority. So you have to check on each carbon which group is high in priority, and then look at the whole molecule and see how they are located on the whole molecule. So this we find out the groups of high priorities are on opposite side of the double bond. So this is E isomer. You can draw the Z isomer for this by just they're changing this and this. Oh, let's try a different situation. So I have this alkene on this carbon. Let's check which of these side products. Obviously the iodine side. Now on this carbon, this obviously has bigger molar mass than this propyl group. As I said, cyclopentane group, so this is higher. So again, this is an E because the groups of higher priorities are opposite side. This is E because high priority groups are on opposite side of the double bond. So we have this molecule. Now each of this side, let's examine this side. On this side, this carbon is bonded to this carbon is bonded to carbon. So we have to check which elements are bonded to this carbon. Now if I expand it, it's bonded to bromine, so that will make this group high priority over this. Yeah. It doesn't matter if there were 3 fluorines here. Even if this was fluorine, this was fluorine, this will still carry the higher priority because of the bromine. Now again we have this situation. We have CHI, I stand for iodine. Now this one we have C. So we have this carbon and this carbon are the same elements. This carbon is bonded to chlorine and 2 other chlorines, but this carbon is bonded to iodine. So this group will be higher priority than this group because of the iodine. So immediately you see the high priority element is bonded to a carbon, then that one takes over the priority, no matter what is or what other thing is bonded to this. So this one we have 3 chlorines, but the iodine, since bonded to this carbon, this group will take the priority. So now we have high priorities on the same side of the double bond. So that means that this is a Z isomer. They are on the same side of the double bond. So that's easy system of naming alkene isomers.